Hello, can you all hear me?
Yes, sir.
Thanks, madam.
Happy Teachers' Day, sir.
Oh, thanks, madam. Yeah, thanks everyone, by the way. Let's just wait for 1 or 2 minutes for as many students. So I updated the feedback from each of the questions for the diagnostic, almost all questions. So I tried to add pointers, references, a couple of conceptual questions to aid better understanding of the question or related questions, things like that. So take a look at those. Today's agenda is very, very simple. We are going to we are going to like look at all the questions and discuss hints and strategies for that. A nice way to, okay, so for those of you who joined right now, we are going to look at one question at a time. For each question, we'll start with students who couldn't answer it correctly. We'll hear from them. Then we'll hear from students who answered the question correctly. So we'll try to hear both the sides of the coin, and then we'll just go through the questions sequential. Okay, it's going to be very, very simple. That's I mean, just a simple agenda, and the objective is to not give you all the answers, all the concepts in today's class. The objective is to still give you sufficient time, sufficient hints, so that you could go try back and try to get the answers by yourself. So that's a major objective. So as I mentioned earlier, even those who have answered questions correctly will get a chance to actively participate. So all students, I hope, can actively participate. Okay, is that clear? And today we need Anu. If you try to speak, we couldn't hear you. Maybe you should change your mic, improve or mic or something.
So now is this okay?
Mildly, yes. Sir, this is okay. I could hear, but it's not that clear.
Okay.
And so, as usual, today, comments and all that, just speak out. And we also try to use chat as much as possible. Let's go sequentially. That makes things very simple. Okay. The first question, rescue teams deployed dash and disaster hit areas combat dash. A lot of difficulties to save the people. Okay, simple question. How many of you got it correct? Okay, so couple of you. So these questions, let's hear from. Okay, so most of you. So how do you approach such questions? Is it like your general, some things that you picked up, normal English grammar skills that you picked up over time, or like have you done anything special to answer these questions? Can we hear from one or two students?
So general English only.
Okay, so yes, general, usage of language. That's what it boils down to. So some of you might have done it. Some of your classes might be going on in regional languages, might be in Hindi, things like that. All that is fine. So the only thing I want to share about this English grammar general aptitude is when I went to, when I started my first year in undergrad, I could not speak a clear sentence in English. So I studied in a state board Tamil medium school. So I couldn't there were English and all that, but I couldn't speak. Then by the time I left IIT, I started speaking, and then over the course of years, this is where I currently stand. So if you find language to be a barrier, I think most of you in this class don't find that, but still, uh, if there are any issues with precise grammar and all that, that will correct over time. So that's the only thing. Okay, so let's go to questions that needs more strategy. Okay, let's start with this thing. How many of you did not get it? Okay, so actually again, yeah, many students did not get this question. Thanks for raising your hands. So, like, why did you find this question difficult? Can someone explain why they found it difficult? Okay. Do all of you see this as a very straightforward question right now?
So complicated, sir.
Sorry?
It's complicated.
Complicated.
It actually looks complicated, sir, but it's kind of easy.
Okay, yes, that's actually what it boils down to. If you're looking at it for the first time, it might look complicated. And
Yes.
I specifically understand that other students comment why it looks complicated and all that. If you get used to it, if you understand what it's saying, it will become very, very simple. Okay, so I do this correctly. So all it says is, let's look at, this is just composition of functions. So we have f of x is x squared. So what is f of x? Now let's look at one layer of complexity at a time. So if you know this, then we can go ahead and say you call this g of x and find f of g of x. What is this? This is just wherever there is x, substitute f of x. So f of x squared. So instead of x, I wrote f of x. And then what is f of x? We know it's x squared. So x squared, that power 2. And this becomes x power 4. Fine. So we know what this is. Let's call this g of x. Then what is this term in the numerator? It's f of Prithvi, can you please answer? So in terms of g of x, what is the numerator? Prithvi, are you there?
X power 4, sir.
Okay, f of x power 4, which is like the g of x. Okay, thanks. X power 4. So now wherever there is x, you substitute x power 4. And that's it, okay? It looks complicated, but it's very simple as one student pointed out. Did you learn it, Prithvi, now?
Yes, sir. Very
Okay,
much.
thanks. Yeah. Okay. This question, again, there are questions, usually one question, standard question like this.
So,
Things are,
sir, one more question for previous, sir. Why did they give you infinity and all, sir? Minus infinity to infinity and those, yes, sir, minus infinity, comma infinity. Why was it given and all, sir, then? The
why
question.
was it given? So usually, when you define a function, you also define a range. In this case, so okay, whether this is open or closed is the only difference that would show up. But for this question, you can kind of ignore this detail. X
Okay,
were
sir.
any
Fine, sir.
range, this would work. Okay,
Okay, sir.
so
Thank
this
you,
is
sir.
like if it were a optimization problem, find maxima or minima, then this might start mattering. Right now, it doesn't matter.
Okay, sir. Thank you, sir.
Okay. And there is one. Usually, there is a text inference question like this, and I think most of you got it right. Right. The only thing you need to be careful about is make sure if there are like uncertain or words that express doubt in the choice, that doubt should be reflected here in this paragraph. For example, questions from biomechanics will likely be more basics. Yes, likely to have less basic questions. That's what it says, right? But if you have to look at this sentence, it says there will be, which is a very certain assertive statement, which doesn't match with this, this likely uncertain scenario that is there over here. This is one thing that you need to watch out for if you are not used to this type of question. And of course, there is a choice saying sun rises in the east. Just because it's true doesn't mean it's correct. It need not be stated in this paragraph that they have given. Just be careful about those 2 points. And I think most of you got this question correct. Question number 7. How many of you did not get this question? Many of you did not get this question. So, yes. Do you all know the answer to this question right now?
Yes, sir.
Okay. Is there anyone who still doesn't know how to answer this question?
I don't know, sir.
Please, Madani, we couldn't hear you.
I don't know, sir.
I don't know, sir.
Okay, so there are students who still don't know how to answer this question. Okay, so let's try to at least, let me think out aloud about what is given over here. Find the missing element in the following figure. And they have kind of given like 2 triangles with numbers in all these corners. We have 5 and 9, 2 numbers. Then we have some characters over here, X, H, N, T, and we want to find what this missing element is. So what is the biggest puzzle at this step in completing this figure?
So one thing I noticed was if you add 5 and 9, you get 14, which is the number, which is the position of n in the table. But then that didn't work for the other sides, so I just left that idea.
Yes, sir. Even I tried till there and I just skipped the question or marked it wrong, sir.
So like T is 20 and X is 24. If you add them or subtract them, still you don't get 14, which is n's position.
Can I get back to this question again? When we go through this, go through each question, in depth. Can we do it at that time? I did come across this issue when I was making the key, but after a minute or so, I got a very, very simple logic. But for some reason, we are stuck somewhere. Let's go give it a try. Tuesday, first thing, let's look at this problem. Okay?
Okay, sir.
Okay, thanks. Okay. Okay, it was estimated. How many of you? Okay, so in this question, most of you made one mistake in that you did not look at this thing more than the original estimate. So most of you did, I think, chose, I think, one of these options, right? The 3 days or, yeah, you chose 13 days. Is that correct?
Yes, sir.
Yes. So that was a very common mistake.
No,
And,
sir.
Sorry? You did not do it, Prithvi, that way? Okay. So how many of you, could not get started with this problem? Anushri. Okay. Rest of you, all of you were able to start with this problem? So,
Yes.
okay, this is not speed, distance, and time. This is like known as work and time. The standard trick here is simple. So try to convert all this information into one units. Usually man hours, if you're talking about hours. In this case, convert it into man days. Okay. So for example, it takes 52 men to do this work in 10 days. What it means is that it says the amount of total work involved is 520 man days, right? So this problem boils down to looking at this particular unit. Then if 10 of them, 12 of them leave, we know rest 40 people are there. So how many days does it take to finish this 520 man days work? That's what this problem boils down to. Anu, do you get the logic now?
Yes, sir.
Okay. So
Yes, sir.
yes, in fact, this is one of the simpler work time problems. Okay, and the trick always boils down to look at everything in a common unit, man hours or man days. The problem should be like very simple. For in this case, it's like 520 by 40, and so this turns out to be 13, right? Yeah, 4 times is 52, 13. How many more days? The answer is 3. So convert that into a single unit. Okay, Anu, did you get this one?
Yes, sir. I got some.
Okay, now all of you can answer. At least this is a very simple version of these type of questions. Can you start answering that? Can you approach that problem?
Yes, sir.
Yes, sir.
Okay. Okay. This was a slightly hard problem, but again, if you know the trick, it's very, very simple. How many of you got this correct?
So I tried it later and got it.
Okay, so and how much time did you take, Madangi?
2-3 minutes. I'd made a silly mistake before, then I
Uh-huh.
did
Okay, you made a silly mistake before. Surendra Raj, what was your experience?
Sir, I already know these formulas since I attended my aptitude exams. Sir. So I know the shortcuts formulas for these sums.
And okay, so let's first hear from Madangi on what her approach was, and then let's also hear what the shortcut formulas are. So, Madangi, what was how did you approach the problem?
So I used the formula of addition of consecutive integers n into n plus 1 by 2.
Okay.
So, but during the exam, I did n into n minus 1 by 2. That was my mistake.
Okay,
So,
and how did you separate odd numbers and even numbers?
okay, sir. So so from a first 50 odd numbers from 1, 3, 5, 7 till 99, I can write that as 1 as 2 into 1 minus 1, and I can write 3 as 2 into 2 minus 1. So 2n minus 1. Sum of 2n minus 1.
Okay.
Then I
Okay.
can separate the sigmas and calculate.
Okay, so you found a pattern over there. Surinder, what formula did you use for this one?
So simply the sum of odd integers from 1 to 100 is n square. That is number of odd numbers from 1 to 100. That's it. If you know the numbers from 1 like 1 to 100, how many odd numbers are there? Simply square it. That's the sum of odd positive numbers.
Okay, so you seem to have gone by formula, right? That requires a lot of memory. I would approach this somewhere in between what Madangi said and what you said. Okay, and so the trick for this problem is you need to know one thing, which is okay. Given some consecutive numbers, say we have like we start from 3, 4 till say 97. How many odd numbers are here? How many even numbers are here? Can someone quickly say that? Okay. So given any n1 and consecutive numbers n1 to n2, the number of odd numbers and even numbers here has simple expressions. Okay. If you remember that, and that formula is not like, you can see why those simple expressions show up. Doing the sum is very, very straightforward. So take the, say there are like no odd numbers, take no and multiply that by average of these numbers. Okay. So the average here is 50. Agree?
Yes, sir.
Average of the odd numbers is 50. Do you agree with that?
Yes, sir.
Okay. Similarly, so what's the average of the even numbers here? What is an average even number in this list? It will be 175. So 150 plus 200 by 2. 350 by 2 will be 175. So this is an average value of a number in the sequence. Okay. And
Yes.
now how many such average values are there? Take this number of even numbers here. This number of even numbers. And this has a very simple formula. All you need to do is to remember that. And it's not hard remembering this formula. Okay, so I'll give that formula. Try to figure that out. Write 3, 4, 5, 6, and try some special cases 3, 4, 5, 6, 7. Try to find a formula that gives you the right answer for number of odd numbers and even numbers.
So I didn't understand if you have given 3, 4 up till 97, how to find the number of odd numbers in that?
Yes. So given the starting value, given the ending value of a sequence, continuous sequence, how many odd numbers are there in it? How many even numbers are there in it? That is a very simple formula.
Yeah, an is equal to a plus n minus 1 into d.
Yeah, something like this. So it boils down to this n2 minus n1. If it's an odd number, it will be plus 1 by 2. If it's an even number, by 2 plus 1. So go try to find out the number of odd numbers and even numbers in a given sequence. Okay. Take that number, multiply it by an average value in that sequence, which is straightforward. For 1 to 100, the average number is 50 by symmetry. 150 to 200, average number is 175. Okay, so go find what this formula is. If you can't find it, we'll look at it and when we discuss this again. For now, is this good?
Yes, sir.
Okay. And again, the problem in gate 20 was like simpler compared to this. But this is a very common sequence-based aptitude question. This is very common. And once you see this formula, it's straightforward. Okay. This one, how many of you got it correct? Okay, Anantha Krishnan got it correct. Surinder Raj. So most of you, okay, so about 4 or 5 of you got it correct, right? Fine. So those who did not get it correct, what were the mistakes you are doing? Did you, okay, did any of you got it wrong? Went back, tried it again and got the correct answer?
So I tried again, but I couldn't figure out the mistake. I got the same answer, same wrong answer.
And what is your answer?
My answer is very weird. It's like 140 is to 112.5.
Okay, so okay, we'll get to that. So did anyone initially got it wrong and then figured out the correct answer? Okay, so all of you who got it wrong seems to still have it wrong, right? So let's hear from students who got it correct. So Anantha Krishnan or Surinder, can one of you explain what you did here?
Yes, sir. Actually, first we need to know the number of boys in the arts, right? So it's
Okay.
boys in arts, 2 girls in management. So we have to consider the arts percentage. That is total 2% of 5,000 total. So
Mhm.
2% of the 20% of 5,000 are in arts. Okay,
Okay.
and also in arts 30% of 1,500 we need to calculate, not 5,000. So 30% of 1,500, something around 750 I guess,
Okay.
and you have to subtract that from the total number from arts of 20%, so we'll get the number of boys,
Okay.
and accordingly have to do the other way
Yes.
for management also.
Yes.
So I have a doubt. So
Yes.
what Surendra said is first you have to calculate 20% of 5,000, which is the total in arts,
Yes.
and then find 30% of that 1,500, which is the total girls in arts.
Yes.
So I just did one thing. Instead of finding 30% of that, of 1,500, I found 70% of 1,500.
Okay.
Instead of subtracting, I directly found the. So if these 30% is girls, then 70% is boys, right?
No. So among the 1,500, 30% is a girl art student. You
Yeah.
cannot say 70 of them like boy art student. You cannot say that from here. With
How
this, okay. So in fact, what Surendra said is correct. Let me at least tell you how to proceed with this problem and explain where the trap is. Okay. So we want two things. Okay. So let's call boys as B, girls as G, management as M, and arts as A. Okay. From this figure, okay, what are the things we want? We want ratio of boys in arts. So we want B in A, and we want girls in management. We want G in M. Agree? I've just like converted the question into simple alphabets. Okay? Number of boys in arts and number of girls in management. Now, can we get number of boys in arts from this figure directly? We cannot get that. Okay? We can only get the number of students in arts. Can we get the number of students in arts from this figure?
Yes, sir.
Okay?
Yes, sir.
That is straightforward. So find the number of students in arts. Then number of girls in management we can directly get from this figure. Correct? 15% of 1,500.
Yes.
Then how do you find the number of boys in arts?
Subtract.
Find the number of girls in arts from this figure. Subtract total number of students in arts, this part. Okay? Malingi, do you follow the logic that I said?
So yeah, I'm understanding, but then why is 70% of that wrong? Instead of subtracting,
Okay, 70% of 1,500 is, you are looking at this this chunk over here. That is what 70% of 1,500 means. So now we are starting to look at engineering students, commerce students, science students, all of them, all girls.
no, sir, not of 1,500. 70% of students in arts.
70% of students in arts. So where is that 70 coming from?
Because 30% of students in arts is girls. So 70% of students in arts is boys.
Yeah. This is where that the mistake is happening. 30% of students in arts is not girls.
Okay.
30% of students in arts is not girls. Okay.
Oh, okay. Yes, sir.
Okay. That's a trap in this question.
Yes, sir. Yes.
Okay. So the simple thing is what I did here. We want boys in arts, girls in management. We can find girls in management from this chunk. We cannot directly find boys in arts. We can only find students in arts. So find girls in arts and then subtract it.
Yes, sir. Yes, sir.
Okay. So yeah, this is a trap, and you fall for it once or twice, and then like it's straightforward.
Yes, sir.
Okay. So pie chart is a bar chart, pie chart, and has this line graphs. 3 standard data interpretation questions, and they always put this trap in this pie chart. Okay. Now you figured it out, right?
Yes, sir.
Okay. So did others Did you get anything from this conversation? Okay, those who did not know how to answer this, did any of you learn how to answer this? Or found the strategy or found the problem with your line of approach? You can either raise hands or like, you can say you still don't understand. All of you understand it?
Yes, sir, understood.
Okay, thanks, Ira.
Yes,
At
sir.
least- Okay, thanks, Isam. So, okay. So, a couple of students now you are starting to understand. So, there is a trap in this question. You fall for it once or twice, that's it. Then you know that trap. Okay?
Okay, sir.
So what is the correct option here?
The correct option here, I have to say from memory, I think 22 is to
Sir,
9.
2:1, sir. 2:1, I guess.
2 is to 1 now. Oh, hold on a second. Let me also actually.
The number of boys is 550, sir, and
No.
girls is 225.
Yeah, 2 is to 1. So the correct option here is 2 is to 1. So because it is there in the key that I gave, I did not like remember what the answers are. So if any of you want to know the correct answers, best if you go to your diagnostic, you can see all the answers. You can also see lots of comments about from me. Essentially, what I said here, I have left it as a comment. Find G not
what
G
was the
num.
answer?
2 is to 1.
But sir, it's marked 22:9 for me.
No,
Yes,
it's
sir,
2 is to
for
1. It's
me
marked 2 is to
also
1
it's
for everyone.
Yes, sir, for me also it's marked 22:9.
22:9.
Yes, sir. For me also 22:9.
I see. Okay, this is some Google form error. If maybe I might have changed the key. That's why you're seeing this. I will update the keys for everyone, all of you. Okay.
Okay, sir.
Okay,
So
sir.
the correct answer is, so yeah, I made lots of new comments and all that. So let me re-release the score so that you can see the updated keys. Okay. This question, it's a straightforward. They usually have a simple basic math definition question. You know, whether what is the order of this differential equation? Is it a parabolic, elliptic, partial differential equation? Or given a differential equation, whether it's, in this case, critically damped, over damped, under damped. Can all of you see the correct answer here for this one?
Yes, sir.
Right? Is there anyone who doesn't know how to still answer this? Okay, so I presume that most of you know how to answer this. So as I said, here classification of roots. Question could be classification of PDEs. What is the order of PDE? What is the degree of PDE? Basic things like that. Okay. What is plantar flexion? How many of you did not get this correct? All of you got this correct?
Yes, sir.
Okay.
Yes, sir.
Okay, great. So just make sure that there were two minor traps here. So movement in the sagittal plane and movement in the sagittal plane. So it's a very generic statement. It doesn't, it's not specific for the ankle. So because of that, there is slight trap there. But okay, plantar flexion, C is the correct answer, right? Heel is lifted off the ground, correct? Is that
Yes,
correct?
sir.
Okay.
Yes, sir.
Okay, so this is
Yes, sir.
straightforward. Now you know what to do, right? Make sure you know what all this kinematic terms are. Flexion, extension, plantar, all those terms. And in the feedback, you also left some nice references on that has elaborately list all this terminologies. Okay, go take a look at that. Here, okay, match the equipment with the property measures. How many of you did not get this correct? Anushri, okay. So what was the difficulty here? Okay, Anushri, Mihir, a couple of you. What was the difficulty in this question? Can either of you mention what the problem is?
Sir, everything was mixed, sir. Like you tested everything on, like you gave for measures of like biomaterials characterization, and you gave also its properties. So this messed me up a lot, sir.
So first of all, you notice some of this were already there in the question that we asked. So I was expecting you to know the definitions, not just the right answer for say in vivo elasticity dimensional analyzer. I just did not expect you to know that. But when it comes to, as you said, biomaterial characterization, we need to know what a rheometer. And, so what does scalar mean? Do you know what the Latin root for scalar means? What is scalary?
Heat, sir.
Something related to heat, right? Thermo. Can you make that connection over here? Then dimensional analyzer from the gate exam is in vivo elasticity. Then you have two options. These two options are same. Both are viscoelasticity, right? The key here is start looking at in fact the best way to deal with many antonyms, synonyms, GRE words is to start understanding their Latin roots. You learn one root, it opens up understanding of 50 words. You don't memorize 50 words, you memorize one root or understand one root, you apply it for 50 words. So, and in this case, calorie is just heat. What is related to heat here? Thermomechanical. Even if you did not know this, you could answer this, but these are standard biomaterial characterization techniques. And rheometer is certainly there. Dimensional analyzer was there in the last year's syllabus. Okay.
Yes, sir.
Okay. Match the biomaterial property. I think most of you got this one correct, right?
Yes, sir.
Yes. This is, at least we discussed that in the sample classes. Cobalt chromium is used for orthopedic joints, and super elastic or pseudo elastic, you can like really squish it and put it inside the arteries and do that. There is a minor terminology issue here. When we look at shape memory alloys and super elastic alloys, I will explain them. But for now, shape memory effect, it's heat induced. Super elastic is self-expandable. Okay, so that's straightforward. And do you know, okay, can someone say what is the problem of calling super elastic to self-expandable here? We can also call shape SMA as self-expandable. Can someone say why that is the case? Okay, I'll get to that when we look at SMA in some detail. Okay, but for now, this is the correct answer. But SMA can also be associated with self-expandable vascular stents. How many of you did not answer this question? Okay, many of you did not answer this question. Okay. So, okay, at least I have one hand. How many of you did not correctly answer this question? So, all of you correctly answered this question?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So, okay, for the couple of students who did not attempt this or correctly answer this, so all the correct statements, answers are directly here in this figure. So we know what, say for example, long TE, long TR is written as T2 wave. And short TR, short TE is written as T1 wave. So just all the correct things are given over in this figure. The reason I gave that is just because a question looks very new, don't skip it. At least at the end of the exam when you have time, read the question completely before you skip it. This I would suggest as an example for that. Some of you did not attempt it, or some of you actually got it wrong. So because a question looks very different, don't skip it. Okay. This question, okay. This question was slightly tricky in the sense that we can make one straightforward connection. How many of you got this question correct?
I got so.
Okay.
I also, sir.
Okay, so a couple of you. Did you all clearly know the answer, or did you make some guess?
No, sir.
I
Clearly
knew
know the
2
answer.
of them.
Okay. You all clearly knew the answer. So you knew which energies corresponded to which of these effects. And so by that I mean you also know what all these effects are. Is that correct?
Yes.
Okay, great. So for others, what did you feel about this question?
Sir, you can actually eliminate 2 options in the beginning itself.
Yes. Can you elaborate more, please?
Sir, pair production, since that requires higher energy, so you can actually eliminate 2 options. I think you can eliminate B and C.
Yes. Yes, that's correct. One of first thing notice. So though this range is high, this extreme is high, 30 mega electron volts. This is this is small, 26 kilo electron volts. So pair production cannot happen with this amount of energy, with this amount of energy. So the pair production needs this amount of energy. Okay. In fact, I think it's almost equal to this. If you find this mc square for an electron, you will find it to be half of this value. Because it's a pair production, 2 mc squares will be this value exactly. So based on pair production, if you knew that physics, you could rule out this option, this option. What you're left with is 2. And at this stage, having eliminated 2, I would consider guessing 1. But if you also know the underlying physics of photoelectric and Compton scattering, you can go ahead and actually answer this question. Okay, but for now, at least start eliminating incorrect answers. This is a nice example for that.
Sir, what is the right answer?
The right answer is, so Compton is directly, I think, mapped with the right one. So yeah, I did not. P is 2.
D is the right.
D is the right answer.
D is the right answer.
Okay, sir.
Okay. Okay, and thanks for helping me out. I don't remember the key right answers and all that. So I think most of you know it. So those who know, give the answers, okay? Okay. Okay, this question, most of you did not get it correct. And so, okay, how many of you choose this option? Okay, one student. So there are at least, okay, a couple of you, in fact, yeah. A couple of you chose from density somehow becomes 1000 to 1500. You thought the time would increase to 1.5, is it? Okay. How many of you answered this correctly, or how many of you know the correct answer?
I got it, sir.
I got it.
Okay, so a couple of you. Can one of you please explain?
Sir, so that day in class, Satabisha told the formula for velocity of ultrasound in a tissue. So she told it is root of 1 by k rho, k being the bulk modulus and rho being the density. Using that formula, we can get it.
Okay, slight correction in what you said. K is
Sir,
compressibility,
Oh, sorry.
which is 1 over bulk modulus, right? So speed is proportional to square root of, inversely proportional to square root of density.
Okay.
Yeah, so that is the trick. I mentioned this in class, but yeah, that is the trick. So it's not inversely proportional to rho, it's inversely proportional to square root of rho. So this is the correct answer, right? If you use that.
Sir, I used another formula, but the same answer, sir.
And which formula is this?
Acoustic impedance, rho into velocity. Acoustic impedance is rho into velocity, and velocity is distance by time. So using that, it is the
Z
same
is,
tissue. So acoustic impedance is same. It is same soft tissue, sir. So acoustic impedance is same. So it's nothing but rho velocity. So rho velocity, and velocity is distance by time. Rho by t. That's it. Distance are same.
Distance are same. Okay. And did you get?
Yeah.
Which one did you get?
1.5.
1.5. Wait. First of all, so you are saying this impedance is rho times C. And from this, so impedance is, notice first of all, rho changes and C changes. And because of that, Z also change. Okay. So Z is not an invariant here. You cannot use that. What is an invariant is or what can be best characterized as the speed itself.
Okay, sir. I understand.
Okay? Yes. Okay. So understand this, and next time, of course, in GATE, if they ask you, they also change the tissue bulk modulus or the compressibility. Be prepared to answer this. We'll try to answer why this speed has this particular form. We'll at least try to get a feel for it when you go deep into this question. Okay. And this is a simple, once you know this relation, it's a simple speed distance time problem. Okay. Okay, so how many of you, did any of you pick all the correct answers, or do you know all the correct answers here? Yes, Mehta, please.
Yes.
Okay, Hema, okay, there is a very straightforward answer, which is Satabisha. Yes, I have been waiting for you to speak up. So there is one straightforward answer here. Which one is that?
D.
So D.
Okay, so many of you think the straightforward answer here is D, right? Actually, the most straightforward answer here is D. Okay, but yes, D is also straightforward if you know some properties of Laplace transform. Okay, everyone here, do you agree D is the correct answer? Do you agree with it?
Yes, sir.
Yes, sir.
All of you. Okay.
Yes, sir.
Now,
Yes, sir.
how many of you don't agree D is also a correct answer?
Sir, I do agree B is a correct answer.
Okay, let's wait. Let's hear from others, and then I'll get to you, Satabisha. Others, is there anyone who doesn't agree B is not a correct answer?
I don't know, sir. Is it correct or not?
You don't know? Is it?
Is it right or wrong? I don't know.
Okay, is it right or wrong? You don't know. Okay. Is there anyone other than Satabisha who thinks B is correct?
I agree B is correct.
Okay, so okay, you agree right now. Okay, but Satabisha needs to get the chance. Why is B right, Satabisha?
Sir, actually, I have read this in a note. So I know this. I don't know exactly the reason, but it was like written in a note I have.
Okay, so it's written in a note that you have from that year. Madangi, so what's your...
So I tried it after your feedback in that chain. So so these two functions in time domain are multiplied. So their Laplace domain, convoluted. So their Laplace domain will be multiplied. Laplace of u of t is 1 by s. Yeah, u of s into x of s, and u of s is 1 by
Laplace
s.
transform of step function is 1 by s.
1 by s.
1 by s.
Okay, one of the most important properties based on convolution theorem, Laplace transform of convolution of two functions is product of the Laplace transforms. Okay, if you did not know it, learn it right now. Okay, so here we have a convolution. If you take Laplace transform of this convolution, we get the product of the Laplace transform. And u of s, Laplace transform step function is 1 over s. That's it. Thanks, Madhangi. Yeah, I'm glad at least someone found it. Those others, this is a very, very important relation. At least recognize such a relation is there right now. Fine?
Okay, sir.
Okay, great. This one, do any of you don't know how to answer this right now? All of you know how to answer this one?
Yes, sir.
Okay, so I presume all of you know how to answer this one. I have also put up a video on how to do this even odd functions. If you don't know, go take a look at it.
Sir, I don't know, sir.
You don't know. So Prithvi, in the feedback, I have put the video link.
Okay, sir.
Feedback for this question, I have put the video link. Take a look at it and then we'll discuss, okay? If you still don't understand, we'll discuss.
Okay, sir.
Great. Okay, this problem, is there anyone who did not get it?
Sir, I did not get it.
Also did not remember the formulas.
Okay, you did not remember the formulas. Okay. Is there others who got this?
I guess so, sir, but I didn't know the answer actually. You didn't give me the key. I know the formula, like I know the observational matrix formula alone. So I didn't know if this is correct or right, not.
Okay, so with controllability, control systems is a very standard question. Not sure if this question will show up in this year's gate because we don't have
removed.
those, yeah.
Yes, sir.
With transfer functions, it's not there. All it boils down to is what is the rank of observability matrix and what is the rank of controllability matrix to check if a system is observable or controllable respectively. And those matrices are straightforward. Had it been in the syllabus, I would have actually explained why that matrix has that form, but for now we can just skip this. Okay?
Okay, sir.
Fine. Okay, this question I'm not going to explain. Would someone like to do my job for this one question? How many of you got this correct? How many of you did not get this? Correct?
I didn't get, sir.
Okay, Madhangi, you did not get it?
I didn't get, sir. I didn't get, sir. I don't know my processor.
Yes. Okay, so
Sir, I got one answer correct. I did not know the other.
Sir. Same.
Okay, so if I were to take the exam, I think I will also get this question incorrect. Because I don't know microprocessor architecture. I don't remember so many details. So but this question has showed up a couple of times in the past. In the actual GATE DM paper, we had a thing on memory mapped IO systems, right? So I just converted it into isolated IO systems. And I have given a short table in the video saying what is for. And other than that, I don't want to really probe into details of this. I will get this incorrect if I were to do the exam. I will be honest with this. Okay?
Okay, sir.
Okay. And if any of you are good at microprocessor architecture and want to, if such questions show up in the discussions, you want to take over it, let me know.
Sir, in this type of question, they have said that it is isolated input output device. That means it is said that it is not memory mapped, it is a IO mapped. So basically IO mapped will be only two options. the microprocessor is saying like it is a IO device, not a memory interface device. So the two options B and D will go along it. Like logic and arithmetic operation directly occur in memory map devices, not in IO map devices. So D will be directly, D will be true and B will also be true. They directly can be accessed through in and out instructions.
Okay, Mihir. So as I said, if there are, I'll make sure the key is correct. But if we need explanations, we'll go for you, Mihir, in the future. Okay, with this topic.
Yes, sir.
Okay, thanks.
Sir, this is a trick question because of isolated input output. They mean to say actually it's IO map, but it's saying that isolated input output.
I see. Okay, so I was the one who said this question and I did not think of the trick and all that. So I leave it at that, okay?
So I was also wrong, sir, because of this isolated input output.
Oh, I see.
So I also
So is that the same thing, isolated input output and input output based
IO map input
microprocessor?
output, yes.
It's
From
IO
what I know,
mapped.
yes. From
IO
what I know,
mapped.
they are
Okay.
same.
Okay, okay.
Okay, is there anyone who did not get this correct? So this is a very basic ECG question. First of all, yeah, let's know where they put the ground. And as we proceed further, we need to know what the limb blades are. And this triangle, what Wiggins triangle, Weinstein, whose triangle is that?
Einthoven's triangle.
Einthoven's triangle, thank you. So we need to know what the Einthoven's triangle. Sometimes the triangle satisfies certain relations. We want to know that. Okay. So at least to start with, at least we should know answer to this question. They put the ground and the right leg.
Right leg.
Okay. And of course, number of electrodes in 12-lead ECG.
10.
Basic questions, yeah, 10. 3 limb, 6 precordial, and 1 ground. So basic things like this, start with that. We'll get deep into this Einthoven's triangle, couple of details. Okay. Knee, this one, again, is there anyone who did not get this correct? Okay, so in the feedback, now I have put up references for saying what joint is what, all that. Pretty much all the joints in the body, how to classify them. I have shared links. For now, knee can do this, right? It's called a hinge. And it can also do some torsion related things, bending and torsion related things. That's why it's modified. So the answer for this is modified hinge joint. I shared a nice reference that elaborates or classifies each of the joints. Take a look at it. This question first thing is, can all of you answer this question correctly right now? Is there anyone who don't know how to start with this question? Where to look for information, infer information? Okay, did you attend the bioinstrumentation sample class? Prithvi, Asam?
Yes, sir.
Okay, you attended it, is it? Okay.
Sir, I am facing a problem that in aortic I can find out, but stenosis and regurgitation I am still confused in between the two.
Same, sir. Same, sir.
Okay, so because it's...
Sir, I did the same mistake, but later I found that murmurs are actually associated with regurgitation, because when regurgitation happens, there is this murmuring sound when the blood gets mixed between the valves. And so it will be regurgitation, because I got it wrong. I made it aortic stenosis because it was in the diastolic part. But later I found that there is a murmur mentioned clearly. So I was like...
Actually, no, Sadabhisha, in this case, I don't agree with you. So in the feedback, I put a YouTube video explaining what all those things are. So murmurs can be from stenosis or from regurgitation. So what you all could do right now is it's second right intercostal space. So you know it's not mitral. So you pick either it's A or C, right?
Yes, sir.
Yes. And once you know it's aortic, what happens during a diastole? Does the aorta pump? Is it like heart pumping through the aorta?
No, sir.
Okay. Stenosis, when there is resistance for pumping, that can happen in the systole. Okay. So, but the heart is filling, blood is also like coming back from aorta, that is regurgitation. So during diastole, regurgitation can happen. And as someone said, murmurs can happen during stenosis or during regurgitation. I have put a clean video on this. We'll also look at this question in detail.
Okay. Sorry,
Okay?
sir.
No need to say sorry and all. Just a small correction. Okay? Prithvi, do you have a question? Is that why your hand is up? Okay. So let's.
Hello.
Yes, Abhishek, is there a question?
Sir. Yes, sir. So, sir, in the question, sir, I would doubt that how could it be diastole before the sound S2, sir?
Yeah. So in fact, I recognize this thing. So if I say it's between S1 and S2, and say in this question I said S2 and S1, you might not be able to locate it. That's why I specifically said it's diastolic. Let's say this is systole, this is diastole. We have an S1 here, S2 here, and for the next heartbeat there is an S1. So when I said S2, between S2 and S1, I'm looking at this region. But I knew this confusion might arise, which is why I added the diastolic in the question. Okay. So this S1 is from the next heartbeat. Okay. This question I explained in YouTube. I also right now gave a clean picture of it in Biomechanics for Dummies. I think page 266. So this boils down to microstructure of muscle fiber. Now they can ask microstructure of axons, microstructure of bones, things like that. Okay.
So what is the right answer for this?
Thick filament, I think, is myosin.
Myosin.
Okay.
But it comprises of all the four. You said, like, I'm confused because.
Yes. So what comprises muscle fiber comprises of all four: actin, myosin, troponin, tropomyosin. In that.
And thick consists of only myosin.
Yes, there are thick and thin. So thin, thick. Thick consists only of myosin. Fine.
Okay. And thin consists of the four. I mean, except myosin and other three.
Yes.
Okay. Yeah. Okay.
Thanks, Adarsha. Yeah. So this thing, I think all of you got it correct, right? So you need to do the summation of residuals. Is there anyone who doesn't know how to do this? Okay. So yeah, a very frequent question. In this case, because the circle is bigger, both these poles lie inside the circle. Do the summation of individual residuals. If any of you do not know that, get back to me and send you I'll send you videos on how to do this. This question, okay, those who did not get it correct in the exam, do you know how to get it correct right now? Okay, can all of you answer this question right now?
Yes, sir.
Yes, sir.
Yes, sir.
Can I move to the next question?
Yes, sir.
Great, thanks. And so now we start looking at properties like what happens to P power n, P plus Ki, things like that. Okay, this question, so it's a multiple select question, MSQ. So the correct answers are C and D. How many of you agree with it?
Sir, I agree with it, but I could not answer both of them because it wasn't getting selected. If I select C, then D is getting unselected, and if I select D, C is getting unselected.
Yes, sir. That's same here.
So Surender, yeah, others can make that complaint. So this time, I did not know Google form allowed only one option, selection of one option, though I had given two options as correct. Next time I will set that question correctly, but with Surender, you should have seen another option. You could have entered C and D.
Sorry, sir?
So the test that you took today, there is a fourth option called other. In that you could have entered C and D.
No, sir, I didn't see actually. I saw only DA. I choose 1 by 3 alone.
Actually,
Plus 1
when
by
you
3.
set the form, there's an option called checklist, which is a square box rather
Yes, yes,
than
yes.
circle. That one will come.
That
Okay.
is for MSQ, I guess.
So means we are only not understanding, is it MSQ or is it MCQ? Like,
Okay. So next time, what will happen is you won't have this dots to choose one answer for. This will be there for MCQs. For MSQs, as I think Madhangi pointed out, we will have check boxes. Fine. So so that it will be very clear. And for check boxes, multiple checking is possible.
Yes, sir.
Fine. So we'll make this correction
Yes,
in
sir.
subsequent diagnostics. Okay, but right now, all of you agree with this answer? Two choices?
Yes, sir.
Yes, sir.
Great.
Yes, sir.
And
Yes,
if it
sir.
says negative or positive, it will become one of them.
Okay.
Right?
Yes, sir.
Okay, sir.
Is there anyone who doesn't know to answer this question right now? So we derived this relation in class, right? In the sample class.
Yes,
Linear attenuation coefficient and half value layer, right? Assuming half value layers. All of you know to do this? Know the relation? Even if you don't know, can you derive it in less than a minute?
yes, sir.
Is there anyone who doesn't know to answer this? Okay, so I'm going to the next question. Okay, this I think is not there in the syllabus, right? This year's syllabus.
sir, but it's an application of laser, sir.
Yeah, they can mix fiber optics with laser because
Yeah,
of
yeah.
that it's there. Okay, and in the actual gate exam, they had a, I think, acceptance angle. I changed it to numerical aperture.
Field view they had asked.
Okay, field of view,
Yes, sir.
FOV.
Field of view.
I just converted it to numerical aperture.
Yes.
Okay, just know the definition of this. I think this is numerical aperture is n1 minus n2
N
square.
square.
That's it. Okay.
Yes, sir.
Okay. And I have a video on this explaining all this field of view, acceptance angle, this numerical aperture. Take a look at it. And you'll be at least you will get a start. Inductance. This is a simple rephrase of the original gate question. So, okay. So, inductance is proportional to essentially number of turns square. So it will be 1/4. Agreed?
Yes, sir.
Yes, sir.
Okay. Very straightforward question. Another straightforward question from Beer-Lambert's law, this spectrophotometer. Okay. So absorbance is this epsilon, the concentration and length, right?
Yeah.
All of you could do this. Again, a very straightforward rephrasing.
Yes, sir.
Okay.
Yes, sir.
Okay. What else can they ask based on a spectrophotometer? What other parameter can they ask?
Incident, the emitted intensity.
Yes, there is this transmittance factor that that shows up and characterizing that the ratios of incident and emitted that shows up in the transmittance formula.
So
Sir, I didn't get this.
Yeah, go ahead.
Who is that?
Mihir, sir.
You did not get this question? I mean, in
No.
gate or in the diagnostic?
This question, yeah, diagnostic one.
So
In
this
gate,
is,
the
okay.
2020.
Observance is epsilon CL, right? So the length doesn't change, so it doesn't matter at all. So we have the molar extinction coefficient of 1. Then we have the concentrations, right? The length doesn't change; it's the same. So A2 is this. Take the ratios; you should find it, right?
Sir, it's coming 0.5. The answer is 0.25.
Yeah, 0.25.
0.25 only.
Yeah, 0.25 is the answer.
Correct answer.
Yeah. 0.25 is the answer. It's a very straightforward question. Okay. Let me go to the next one.
So
Yes, sir.
one doubt.
Yes,
This transmittance is 1 by absorbance.
I don't remember it. Can we get back to
Log
this?
of 1 by 3, sir.
Log
Log
of
1 by 3.
Yes. It's not 1 by absorbance. There is a log factor involved there.
Okay.
Okay.
Okay, got it, sir.
Okay, thanks. 1 second. Okay, let me go to the next one. Okay, this question. Okay, how many of you got it in the exam? Some of you got it.
I got so.
You
Sir,
got
I
it.
got
Okay,
it.
great. Yeah, a couple of you got it. Very good. How many of you still cannot get this? How many of you do not understand this? Okay, Anushri doesn't seem to understand. Okay, so a couple of you, right? All you need to do is what is this? So the amount of this energy generated in this, in this glycolysis that is used for this ATP production from ADP. So the total amount is 686. Using that, the converted energy is 36 times 7.3. The converted energy you get from 686. So what is the efficiency? Divide this by 686 times 100. Okay, so you use 686 kilocalories to get 36 times 7.3 ATPs. That's the energy conversion that's happening. Efficiency of this is this ratio. Okay. We'll at least one class we'll look at a deeper look at what these reactions are, what this glycolysis is, and all that. Okay, so and this I think is the right answer. Fine.
Yes, sir.
Okay. Okay, this question it appears like formula based. We'll try to, not try to. We'll derive all this Doppler formulas in one class. But for now, the only question I have is you can eliminate a couple of answers here. Can someone point that out? Any guesses, please? Even if you don't know the formula, anything, you can eliminate a couple of answers here.
First one, sorry.
You are saying you can eliminate first one. Why is that?
Because Doppler frequency is proportional to F. So they both cannot come in the same like numerator denominator.
Okay, numerator. Okay, there is one inconsistency here. What else can you eliminate? Okay, so let me rephrase that inconsistency. We want velocity of blood.
B also you can eliminate, sir.
Which one?
B.
B, no, you can't eliminate that easily. So let me explain what the problem is.
B.
So this is frequency time frequency. Delta frequency is in units of frequency. This is in frequency, say per hertz or whatever, per second, whatever it is. So the frequencies this cannot be velocity. Okay, this cannot be velocity either because this is 1 hour velocity. Going by the units, going by dimensions. But these two on the other hand could be possibly velocities. Going by dimensions, same units, what we are left with is velocity. Okay?
Yes, sir.
Yes. Yeah, so in the gate, they made it numerical. They asked you to substitute and find the answer and all that. I made it much simpler and learn that you can eliminate. Major trick here is when such formulas are given, test dimensions to eliminate incorrect answers. So at this point, my guess is going to be much better. We'll derive this formula in one of the classes. This and a couple of other Doppler formulas. Okay. Couple of you got this question correct. So how many of you still don't know how to answer this?
I got it, but still I am confused.
Exactly, sir. I did it by dimension.
Okay.
Same sir, same sir.
Who was it? Who did it by dimensions?
Sir, Shautabhisha.
I also did that, sir.
I also did that same.
Yes. Okay. You all did a very smart thing that you are supposed to do in gate. Problem like this, try to do if we can get a consistent dimension, what by doing some manipulations here, and it's a numerical answer type, enter that number. Do some dimensional manipulations, multiplying, dividing gives me this number, enter it. That's the best thing to do. The actual trick boils down to the difference between resistivity and resistance. Okay? And we will look at this difference in a subsequent class. But for now, even if you did not know, the best smart approach to answer this is by going by dimensions. Okay, we'll look at this difference when we look at the underlying concept. Fine?
Okay, sir.
Okay, and so this is actually an electrosurgery unit. So this is a question from electrosurgery unit. We have seen a defibrillator. This is an electrosurgery. I was wondering ablator or something like that. So it's known as an electrosurgery unit, as one student pointed out. Again, the answer there is I square R, just that this R will be rho V. This resistivity times this. Where is this? Power dissipated in the tissue of resistivity, current density. Yeah, this current density. Okay. So we'll look at, we'll try to actually see what is rho and what is R. Okay, this question, I think most of you did not get it. Two questions. One is, I did not give sufficient data to calculate the numbers. Can someone guess what the data is? Okay, given some additional information, you could have calculated this, whether it's 61.9 or 94.8. What is that?
Faraday
RT.
Yes.
Faraday
Or
constant.
gas constant,
Temperature.
Faraday's constant, perhaps the temperature. Why is that?
Because it comes in the Nernst equation.
Yes. So if you know Nernst equation, you can substitute and understand. I mean, substitute and get these values. For that, you need R, F, and T. But without that, you could actually answer this question.
Yes, sir.
Right?
Yes, sir. Simplified.
Yes. Based on this extracellular, intracellular potential, concentration differences, you can say which of this potential should be positive or negative. Okay. So this is, again, we will spend a lot of time in this topic. And okay, you need to know what resting potential is, and you need to know how to apply the Nernst potential. This is very important because so they had a I think drug-based question in GATE 2020. They can easily tweak this and make it a corrosion question from biomaterials. The answer to that again depends on Nernst potential. So just get used to it. And the key detail here will show up in the other question regarding membrane potential. What is resting potential? What happens to sodium, potassium, and all that. Okay, this question, what was the change that I made?
You interchange the options.
Okay, all I did is simple. Simple thing, just I interchange the options. And in the video, the actual solution, I explain why, one of that is correct answer. I think 2 is correct, right?
Yes, sir.
Yes, sir.
This question, what did I do? And okay, how many of you did not get this question?
Me, sir. I made a blunder here.
Okay, so blunder. Okay, what was it? Let's hear.
I found again the output at V out, sir, not at X.
Okay, yeah, that's a blunder. Others who try to find the signal here, did you all get it?
Yes, sir.
Yes, sir.
Okay, so now start. First of all, recognizing all these op amps, comparators, differentiators, adders, subtractors. In fact, all those instrumentation amplifiers, all of them, recognize them. Also, for things like instrumentation amplifier, it's good to remember the formula. Okay, we'll derive them when we go deep into this. This question,
what is the second op amp?
Sorry?
The second op amp is what?
Second op amp is a differentiator, right?
Differentiator.
Differentiator.
Okay.
Okay.
Okay, sir.
Right now, just take it for granted. We'll show why this is a differentiator. When we look at this, very simple. We'll also find out what an integrator is. What changes to make in order to get an integrator.
So interchange the R and
Interchange the capacitors.
Capacitor. Yes.
Okay, we'll do that. We'll do that systematically.
Okay.
Okay, thanks. This question, I suppose all of you got it correct, right?
Yes.
Yes, sir.
Yes, sir.
Okay. One of the easiest 2-mark questions in the entire paper. Okay. Okay. Did anyone get this question correct?
yes, I did.
Surender. Okay, that's very
Yes,
good. What is the correct answer here?
I guess 3.
Unfortunately, Surender, no, that's not the correct answer. Okay. Okay, so the second question is, what is the difference between this question and the gate question?
Sir, both are kVAR. Both are given in kVAR because I did the same mistake of overlooking the unit and I got 3 and it was incorrect.
So you are saying the answer is 3 for this one?
No, the answer is not 3.
Yes.
In the gate paper, 10 kVA was given, but here it's 10 kVAR.
Yes. So in the actual gate BM, this was 10 kV, kilovolt amperes. This is kilovolt ampere reactive. So I added this R here. That changed the answer.
I noticed the change you made, but still I didn't get the correct answer. I tried it twice and I got the same wrong answer.
I see. So okay. So you know how to solve this, right?
Yes, sir.
Okay. In that case, let me go verify the number once. I already did it. Let me go check it once again. Okay.
Okay.
Okay, sir.
This question. Okay. Again, I have a nice video on how to approach this question. If you have a lot of
So
time.
for the last question, how to solve it, like to get the correct answer?
Okay, how to solve it to get the correct answer?
Yes, sir.
Yes, we will solve this. But for now, what I suggest is, I have a video on the actual gate question. If you have kilowatt and kilovolt ampere, how do you do that? Okay.
So I did it, but it did not come. I don't know if it's correct or wrong, but I tried it and it came like 5, and the nearest to it was 5.3. So I guess, but I don't know if the method was correct.
I see. So we'll solve it when we look at it. Okay.
Okay, sir. Okay, sir.
Okay. The nearest value of power dissipated. How about this question?
I didn't get this, sir. I tried it 2 times. I didn't get.
I tried 2 different methods. And I think I got 9/8.
9/8, right?
Yes, sir.
9/8 is correct.
Sir.
Yes.
9/8.
Yes, sir.
I didn't.
Okay, so I think I tried it a couple of times. I got 9/8, but the simplest trick is convert this into a Thevenin, and from there, can someone tell me how to get the answer very fast? You can use Kirchhoff's and get the answer, but if you can make this thing into a Thevenin and apply one more theorem, you can get the answer very easily. Can someone say what that is?
Superposition.
You can do superposition. Okay, that would also work in this case. There is one more theorem that could actually
maximum power dissipated theorem.
No, not maximum power dissipated theorem. There is something called Millman's theorem.
Oh.
That is not there in biomedical syllabus. It's there in other electrical circuits topics.
So rather than this approach, if we make the current source into a voltage source by a voltage transformation, source transformation, then use nodal analysis, it becomes simpler in one equation and one unknown.
Yes. In fact, so you are saying convert this into a voltage and a resistor, right? Yeah, which is what I meant by the Thevenin equivalent. Yeah, do that. The answer is very simple. That's a trick. Convert this part, then any approach, nodal analysis, superposition, Millman's will give you the answer very easily. Okay. Again, I have put a video on like at least how I would strategize how to pick the right or optimal approach here. Watch that, and the actual speed comes with practice with this electrical circuits. Okay.
So
this one. Okay, this one is a slight memory based question. Okay, had it been the difference between this and the gate question is this quality factor, right? There they had the natural frequency, I suppose. Correct?
Yes, sir.
Yes, sir.
Okay, so again in a YouTube video, I have given the form for this second order low pass filter. In fact, I have given a very general form: low pass, high pass, band pass. All of that will be there in that form. Memorize that one thing, one form. Okay, that is you need to memorize. You need to know what that second order standard form is. Okay. Is there anyone who saw the YouTube solution and still doesn't know how to answer this? All of you know,
sir,
right?
Sir, what is the equation for quality factor?
Let me try to write it down from memory. I think it's omega naught square s square plus 1 over q omega naught plus omega naught square. Yes. Can someone verify this? Is this correct? Is this a second order low pass filter form? Some of you answered this correct, right?
Sir, Q at 1 by Q is equal to zeta. Is it right, sir?
Yes. If it is zeta, I think it will be 2 zeta over here.
Yes,
Yeah.
2 zeta.
Yes. Yeah, that's correct. But that's not a filter. Zeta doesn't show up in filters. It shows up in differential equations.
Sir.
Okay. So yeah, this is a standard form. Compare this, multiply this, and compare with this. You can find what Q is. Okay, this is a memory-based question. We will go into details. We'll list all these bridges that are there in the gate syllabus. We'll also like analyze how to do this AC Wheatstone bridges. Okay, we'll do that in depth.
This is a measurement part, right?
This is from
complete
measurements. Yes, measurements.
Yeah.
Okay. How many of you did not get this question?
Sir, I made a mistake, but later I could solve it.
Okay, later you could solve, right? Okay, great. Is there anyone who did not get, okay, who cannot answer this right now?
Sir, I didn't understand the YouTube solution, so I tried something on my own. And it was wrong.
It was wrong?
But I don't get why the concept is wrong.
Okay, so, okay. What we can do is we can take a relook at the YouTube solution. We can go one piece at a time and see how to do the simplification. What is there in the YouTube is very standard. That is not wrong. That is there in the standard books. Okay. We'll look at it one piece at a time and make sure we follow the logic.
Okay, sir.
Okay?
Okay.
Okay. Okay, first thing, let's forget R for the time being. Can you all do P, Q, and S?
Yes, sir.
All of you can do P, Q, and S, right?
Yes, sir.
Yes.
Okay.
Yes, sir.
Great.
Yes, sir.
Do you know what
Yes,
is
sir.
RM? What is this thing?
Yes, sir.
What is that?
Sir, like you have to add an extra term.
Yes.
You can like multiply an extra term with BC. So if you multiply BC with 1 and then replace 1 with A plus A complement.
Okay.
Then you separate it and solve.
What is that called?
I don't know, sir.
It's called the redundancy theorem.
Okay.
So if you notice, you need not know how to simplify R to answer this question. Do you all agree? If you know what
Yes, sir.
PQS is, you can answer this question, right?
Yes.
Yes, sir.
That is essentially an example of redundancy theorem. So when there is this combinations of logic, you can simplify it this way. And the derivation is what I think Madangi explained, right?
Yes, sir.
Yes. This derivation is very simple and it goes by the name redundancy theorem. This was not there in the standard Boolean operations I listed, so I just gave it up on this test. Okay, this is somewhat the most different question that was there in the paper. Did any of you get this one?
Sir, I did.
Okay, great, Sadaksha, you got it. Anyone else? Okay. Sadaksha, can you explain how you found it?
Sir, I did, but exactly the term did not come as D. It was D was a part of it. Yes, I just tried it. 1 minute, sir.
Okay, so for this, this is a very standard question from biofluids. The starting point.
I tried to use the pressure difference formula for the maximum velocity, and from there I calculated it.
Yes. Okay. That's how you. I mean, if you remember the formula, you could do that. Else, from this you can calculate this with one integration. Okay. As a primer, I have this biofluids playlist. Take a look at this, understand what these different terms are, and this question can be rephrased in like about 10 ways. So understand the derivation, you can answer this very simply. Okay, we'll go through the derivation in class properly. But for now, to get started, go check the biofluids playlist. Fine. Okay, so this question, okay, gate question. Did anyone get this question correct?
Sir, I did.
Okay, so that's good. Meher? Okay. Satavisha, can you explain how you got this correct?
Sir, I went statement from statement, and by using you gave an explanation like for intercellular and extracellular, that diagram, and using that of comparative study.
Okay. So this is a question from physiology, and we need to understand the resting potentials, which concentration is higher, lower, and what happens during depolarization and what happens during repolarization. We have to understand that underlying physiology. It's partly memory based, but it's one of the basic mechanisms that has a lot of consequences. Okay. For now, this is the incorrect choice, right?
Yes, sir.
Okay, sorry. I mean, the answer, the key is A. A is the correct answer, right? So
yes,
learn that the opposites, all these are correct statements. For now, just start learning from this. We'll get into the details of this in a physiology session. Okay. Okay. Some of you did not attempt this question. How many of you can you please raise hands?
Sir, I did not.
Okay, Sadavisha. Anyone else?
I did not.
Me, I did not.
I also didn't attempt.
Okay, most of you did not attempt. Did any of you attempt this question? Did any of you get this correct?
Sir, I attempted, sir.
Attempted. Abhishek, did you get the correct answer, Abhishek?
No, sir. It's
Yes,
another.
sir. Yes, sir. Obviously, yeah, I got it correct.
Sir, I tried, but it did not match any of the options, so I did not mark.
Is that the case? Okay. So let me, I derived it again twice, the answer that I have. Let's do it once again, when we do this exponential class. But how many of you don't know how to how to answer this, or what is the strategy, or how to proceed with this question. Hemavati. All this says us, okay, I'll briefly give a hint. The strength decay, usually the biomaterial strength decay is exponential. So what happens is, if you plot the strength, let's say sigma versus time, starting with the say 100% value, it drops exponentially. So this curve is like a times e power minus bt. And it says, okay, 0th day it's 100%. Then strength decrease by 40%. So its value is 60 in 10 days and 50 in 20 days. So this value is 50. Okay. So all you have to do is 60 is a times e power minus b10, and then 50 is a e power minus b times 20. Okay. Find b. Divide this, take ln, you can find b. Then once you know b, you can also find a, or you can also circumvent that, how long it will take for it to become 60%. So when it's decays by 60%, what we are left with 40. So 40 is a e power minus b times t. This is the t that we want. So divide this by one of these two expressions. We know b, find the value of t. So it boils down to fitting exponential functions. Hema, did you follow this?
Yes, sir.
Okay, thanks. Go try that. I tried this. I think the key that I have is correct. Let's all
what's
try.
the correct answer, sir?
What's the correct answer? It's 32 days.
Okay, sir.
That's a key I have. I'll go verify it again, just in case,
This is what I did. I got 56 days, but I will check again. Maybe it's the wrong.
Yes, please check again. 56 is a lot. And one thing, make sure you convert this 40 to 60 here and 50 to 50.
Yes, sir, I did that.
Yes. Just let's go verify again. I'll also go verify it, okay?
Okay, sir.
Okay, thanks. This one? Did any of you get this question correct?
Yes, sir.
Great. So Madangi got it right. Oh, you
Yes,
were
sir.
asking about how to draw the free body diagram, this, that. Okay.
Yes, sir.
Great. So I think this will be a very standard question from biomechanics. If it is not a elbow, it's going to be a knee. If it's around knee, it's going to be ankle. Or if it's going to be a hip, perhaps sometime the spine. It's a very, very simple question if you understand how to approach it. There is only one trick in the question. Can someone say where the trick is?
So that 75-degree angle.
Yes. So I have already put a elbow joint problem in YouTube. This tension force, bicep tendon force, is acting at an angle 75 degrees. So when you take moments, split up into components. So this is FB sine 75, and this component will be FB cos 45. FB cos 45 will have zero moment about this joint. Only this FB sine 75 component will have a non-zero moment. That's the only trick. But other than that, this is a very, very straightforward question. So there is a weight that shows up in 7.2. So CG is here. There is a weight in pounds. Okay, so this is like just moment equilibrium. You can get it. Very straightforward. I spend initially I spent a lot of time with this question. During the sample classes, I said we make so many assumptions and all that. We will go one detail at a time. We'll make sure we learn this. because every gate paper I expect a question based on this equations of equilibrium and free body diagram. It's very important. This question has only one simple trick, but we'll learn this in detail before diagnostic 2. For those of you who kind of partially knew how to get the answer but got the wrong answer, account for this moment difference, you will get the right answer. Fine?
Okay, sir.
Great. This again, it's a straightforward question. What is the change in length for a thermal material? We know how to calculate this, right? It's not even traps. These are like just multiply the numbers, you'll get one of this. And the actual trick here is, how do you find this volume, change in volume? Can someone say how to do that? Okay, did anyone answer this question correctly?
Yes, sir, I did.
Yes, sir.
Okay, so can one of you, Ananthakrishnan, can you explain how to answer this?
Sir, first I found the change in length and I made the changes in both the radius and length and then found the volume change.
Okay, so you found one each change, how much radius changes, how much length changes. By that you found how much volume changes.
Yes, sir.
Okay,
Same,
that is. You also did like that, Madangi?
Yes, sir. Same.
Yes, sir.
Okay, so we have coefficient of linear expansion and coefficient of volume expansion. Okay, how are these two things related? So what is alpha L? Alpha L delta T times L. What is this? Change in length, right? Is that correct?
Yes, sir.
Okay, so this is change in volume is alpha V delta T times V. Question is, what is the relationship between alpha L and alpha V? Can someone answer this? Okay, so let's take a simple volume Q, L plus delta L Q. Okay, so as a first order approximation, what would this be? If you neglect higher order terms, what would this be? 3 delta L, L square.
Yes, sir.
Agree? So using that, you can show this coefficient of volume expansion is thrice coefficient of linear expansion. So only a factor of 3 will show up in this form.
For all solids, sir.
Isotropic solids, isotropic, homogeneous. First thing is isotropic. It should expand the same way in different all directions. Okay.
Okay.
And I gave this because this is kind of like an aptitude question. If you knew, as Ananthakrishnan said, if you calculate change in radius, change in length, you can actually answer this. And also, this is a direct example from Parkin lakes. Okay. What is this question number? 1 second. We are in 52. We have like a couple of more. Let's kind of pick pace and just like look at very important things. How many of you answered this question? A couple of you got this.
But I didn't know it's correct or not.
Sir, I did.
Okay, Satavisha, what was your answer and why was it correct? Can you please give a brief explanation?
Sir, I found about that expression and how it tallies with the voxel size. Like, how can I say? Like, it was. It's given that 1.5 is given. It varies with the magnetic field, and so it's directly proportional. So there's 1.5, and about that root over 8 factor, it did not like come directly. Just because it was supposed to increase, I made it multiply. Like I just improvised that part.
Okay, improvise that part. Okay, this is a direct example from Prince and Links, and this is also a very tricky example. Go take a look at it. The answer is not all that straightforward. We need to understand what this voxel size and how this resolution is controlled in MRI. For now, take a look at the example problem. We'll go into the details of resolution in MRI when you look at this problem. Okay? For now, take a look at this directly the example from Prince and Links.
What's the correct answer, sir?
This is, I think, C. There will be a root 2 factor in all C's. Oh, sorry. Yeah, C. Okay. Take a look at this. This is a very, very tricky problem. We'll go deep into it. Okay. For now, take a look at that example. Okay, this thing right now, you all know, right? It's not a major trap that I said. It's like a very simple rephrasing I did. There was like axial resolution, I gave pulse length. There was like
Yes, sir.
yeah, pressure reflection, amplitude reflection coefficient, I gave intensity. Intensity is square of amplitudes.
Yes,
right?
sir.
Yeah, straightforward modification I did. And pulse length is lambda, wavelength times the number of pulses used. So n lambda. Just that. Okay, this problem is same as the biomaterial problem, Schuster degradation problem, again fitting exponentials. I did a very simple rephrase. Did you all get this one?
Yes, sir.
Okay.
Yes,
You all
sir.
know how to do this, right? Directly the gate problem. Minor rephrase.
Yes, sir.
Okay. Okay. Do you all know how to solve this one? How many of you got this correct? Do you all
Yes, sir.
know? Okay.
Yes, sir.
Okay. In fact, this is a very, very simplified version of the actual gate problem. And all you have to do is this integral p of x dx is, from minus infinity to infinity is 1. You have to do that to find this coefficient.
Sir, I did it in a different way.
Okay, how was that? You compared it with Laplace, is it?
Yeah.
Okay, so by now Laplace kind of becomes standard because it showed up in gate. Yeah, that's also your way to do it.
Sir, I did it in the same way too.
Okay. Okay, great. So, okay, if you remember Laplace formula, standard formula, that's very good. Okay. There was a major trap in this question. Most of you fell for it, and it's a very standard trap. Is there anyone who got the correct answer?
Yes, sir, I got it.
Abhishek.
Yes, sir.
Great. Ananda,
Yes, sir. I found it later, sir.
Okay, you found it
Sir,
later.
I also found it later. I did
Okay,
my
so
mistake.
okay, so let's also hear from some other here. Kema, Iram, Kevin, Pradeep, sir.
Sir, I didn't get it, sir.
Okay, so the thing is, when you're talking about maxima and minima, we tend to do this, derivative of this function, put that as 0. That will be an extremum point. Then some of you go ahead and take second derivative, check if the minima or maxima. That's all is fine. But when you are given this, a range like this, a closed interval. So 1 is included here, 6 is included here. In that case, you need to check the boundaries. Because the boundaries slope need not be 0, but it can be a maximum. Take a parabola. If you are looking at, say, in this range, okay, say in this range, the minimum occurs here. The slope derivative, slope is 0 occurs here, but the extremal points could be there at the boundaries. So this is where, see, this is an example where the range clearly matters, and we need to check the boundaries for extremum problems. Major trap, and if you fell for this, don't fall for it next time. Clear? And at one of the boundaries, the value is 41.
Yes, sir.
Great. Okay, did any of you get this question correct and any experiences to share?
I was solving it for so long, sir.
Yes. I purposefully added one question that would take a lot of time. It looks simple, but you need to You need to find
interaction and then have to do the
yes, you need to find
So it
what
was
this
a
point is, what this point is, find the
yeah.
roots, find all these values, then do the calculus. So this is one problem I would do at the end of the exam.
Okay.
Okay, but the details are straightforward. Finding roots of quadratic equation, we can do that. You can find these values, you can all that. It will take time. So you are in the middle of an exam, you have spent like 10 minutes on this. Skip it. It's okay. 2 marks, skip it. Later, if you have time, get back to this. Okay, this one, some of you got it correct. What did you do? Some of you got this correct, right?
Yes, sir.
Yes, Abhishek. So what did you do, Abhishek?
Sir, I just find that mean, sir.
Yes. The problem looks, first of all, we are not talking about normal data, we are talking about group data. In this range, it's 3, in this range, it's 61 61 members are there, like that, right? And we have to find the mean and the standard deviation. But notice all the mean values are different. So if you find the mean correctly, you can answer this question easily. And how do you find mean for the group data? Can someone else answer other than Abhishek? Okay, there are 2 steps. Let me do 1 step and then let's try to fill it up. What is the midpoint of this? 25, 35. So let's say all the members here roughly have age of 25. All the members here roughly have age of 35, 45 and all that. So let's replace this range with these numbers, midpoints. Once we do that, how do you find the mean for this frequency data? So let's do the normal mean. It's 25 plus 25 plus 25, right? Plus 35 plus 35 plus 35. How many times? 61 times, right?
1 times.
Yes, 61 times. And like that for all terms. Notice and divided that by how many times that?
Total number
25 years, 3 plus 61 plus and all that. So this is essentially midpoint of this range, 25 times the frequency there, 3 plus 35 midpoint of this times frequency there, plus divided by total numbers. Fine. Do this, you can find the mean is 54. With that you can answer. And the same thing extends to standard deviation more. But you don't have to spend so much time. You can answer it right away as Abhishek did. If you did not know, did you learn this right now?
Yes, sir.
Yes, sir.
Okay, great. Numerical methods. Okay, many of you did not get this correct for some reason. There is no major trick here. I just changed the replace angles. I replaced 50 by 20 and 20 by 50. And whatever we did for the gate problem, if we do it here, we can get this. Only thing is, if you take the TKA line, I think this will be like this. So it will be, the answer will be...
Negative distance is coming.
Sorry?
Negative distance.
Yes, the answer will be negative in this side. Yeah, that's the only thing. So I said enter it plus or minus.
Yes.
Just the gate problem, the angles interchange. Okay, go try that and try it out. This one, okay, if you did not get it at this time, go look at the gate solution I provided. In there, I explained this resolution could be given in cycles per mm or in line pairs per mm. These are standard units, or lines per mm. In this case, I gave it in lines per mm. Convert all of this into pixels per mm, and you can calculate the data very easily. Okay. If you did not get it correct, go try it again, please. Check that video and try it again. Can you do that?
Yes, sir.
Okay, thanks. Okay, there are like 5 more questions. We'll finish it in like 10 more minutes. I wanted to explain the underlying concept here. I tried that, but I made a mistake in setting up the question. I wanted answers A, C, D to be correct, but only D is correct. Okay, first thing. Can someone say what change I should introduce here to make A correct?
Sir, that multiplication is not required.
Okay, it's not required. That is one thing.
The addition, it should be added.
Oh, it should be added. No. B cannot be the right answer. Cannot be at all. So let me say the mistake I made here. I left a negative sign here in the exponentials. Okay. So we all know this attenuation law by now, right? So n is whatever number of photons you start with, that times e power minus mu. Do you all know this?
Yes,
we all know this right now,
Yes.
right? So now at this point we start with 2. What will be the number of photons at this point? So notice in this region mu doesn't change, right? For soft tissue it doesn't change. Correct? So it's 0.4. So what will be the number of protons at this stage? This formula.
Yes, I understood.
Yes. Okay. So it's e power minus mu dx. So it's 0.4 times this distance 2. Correct? So till this point, the value is 2 times e power minus 0.4 times 2. Yeah, the integral vanishes because mu is a constant. Okay. So till this point, number of photons is this. Do you all agree? At this point,
Yeah,
0.8.
yes, sir.
Till here,
Yes,
number of
sir.
photons is this. Now take that many number of photons, and it passes through, say, through blood and gets here. So you start with this. How much will it attenuate? Into e power attenuation in this region. What is that? Minus. So this is what you start with now at A. Minus. So 0.2.
0.5 into
Yeah, 0.2 into 0.5. So that is what you have here. And what do you have at the end of it? So take all this, multiply that by e power minus
1 into 0.4.
1 into 0.2. This is what I wanted you all to learn in the exam, but I made a typo in setting it up. Okay. And so, okay, there is a minus. I also put some unnecessary integrals. And the integrals are like, okay, the actual formula for homogeneous medium is n naught times e power minus integral mu dx, mu of x dx. Have you seen this relationship?
Yes, sir.
All it says is take a small chunk dx. Okay, the attenuation there is e power minus mu dx. Multiply that at the next dx, at the next dx. So there is an e power minus mu dx2. Okay, this is dx1, the next chunk is dx2. It gets multiplied. Do you agree with this? Start with n naught here. E power minus dx will be the change here. Say mu varies in the medium. Mu is a constant in this medium, right? Soft tissue.
Yes, sir.
Let's say mu is a function of the medium. It varies from 0.4, 0.39, 0.38 and all that. In the case, take small chunks. At each small chunk, it attenuates by e power minus dx. Then at the end of that chunk, you start with this number of photons. This much amount of attenuation at the next chunk. And this goes on ... till how much time it continues, right? And what is this product? What happens to product of exponentials?
Added.
Yes. So this becomes, so this term becomes n naught e power minus mu dx1 minus mu dx2 minus ... all this stuff. And what is a simple way to represent this addition over here? The summation in the limit dx tends to 0 is this integral. Agree? Newton's definition of integral. I wanted you all to learn this simple thing about this formula. I made a small mistake in setting up the answers. But okay, do you see now what happens with this, non-homogeneous medium? Why this kind of formula shows up?
Yes,
Yes, sir.
Some of you? Okay. If others did not follow it, we'll again take a much slower look at it. But the logic is very, very simple. If you know what happens to attenuation in a homogeneous medium, non-homogeneous medium is just integrals. Okay. And for now, this question is, the correct answer is this. Okay. This question is, how many of you did not get this question? Some raise hands, please. All of you can do this question right now?
Sir, I got it now actually. I didn't get
Okay.
it then.
Okay, so Prithvi, your raise hand, what is it for? Can you do it now or you cannot do it?
No, sir, I cannot do so.
You cannot do it now? Okay, so
Yes.
the trick is find out what is the energy of one photon. Okay, and see if this much amount of power is there, how many photons will make this much amount of power. What is the energy of one photon, and in this power, how many photons are there? Try to answer that question. If you still cannot figure it out, we'll do it. There was this kidney ultrafiltration problem. This
Yes.
flow in one pore is this, multiply that by number of pores. The same thing is involved here. What is the energy of one photon? And what is the total energy, watt per second? Okay, do that. What is the energy, equivalent number of photons required for this power? You can get it. Okay, try that out.
Okay.
If you don't get it, I'll explain.
Okay.
Okay, this is a straightforward rephrasing. PMMC. We will look at the derivation when we look at this question. Most of you got this one.
Yes, sir.
Okay.
Yes.
So at this point, the thing that you need strategy is questions that already showed up in GATE. Make sure that you can answer them. Okay. The first thing to do. Okay. In this case, you can write down the formula in like 1 or 2 lines. The derivation. At least you can make sense out of the formula in 1 or 2 lines. Learn the derivation, but if a question has already been asked, make sure you know at least that. And then another, okay, I set a trap in this question. Did any of you not fall for it?
I
How
did
many
not
of you?
fall for it.
I don't think so, FLC.
Okay, so how many of you fell for it?
I
Sir,
fell
in
nicely, sir.
Sir, 3 decimal values a little wrong of 0.1.
But in the actual gate, they had that kind of that kind of
Accuracy.
precision was required.
Okay.
And in fact, to emphasize that, I put this question. And do you know so do you see the difference between this question and the gate question?
Yes, sir. The bounded oxygen content.
Yes, the
And
bound
Yes.
is just
total.
yes, Sadabhisha, right?
Yes, sir.
Yes, thanks Sadabhisha. The gate they asked total oxygen content. In fact, if you were just to find the bound oxygen content, you entered the value. It was not in gate's answer key range. So they were particular about that decimal in this problem. And that's why I just asked you, okay, what is the bound oxygen content? So total is bound plus dissolved. This was the gate question. I asked you just this one. Again, take a look at the video to see what this difference is. This trap was set in gate. Learn it right now so that if it shows up again, you know how to handle it. We couldn't hear you, Sadabhisha. Sorry? Can you type, Sadabhisha, please? We couldn't hear you.
Sorry, sir. Sorry, sir.
Oh, yeah. Speak. Okay, now I could hear you. Okay, so let's magnetic flow probe. Again, straightforward question. C clamp. This is BLV, right? I just rephrased the question. we look at why it is like, I think BLV, is that correct? BLV and replace V by Q over A. Is that correct?
Yes, sir.
Okay.
Yes, sir.
We will see. At this point, I have a question for all of you. So what is this L? Where is this formula coming from? You have a moving conductor in a magnetic field, it generates electric potential, right? So why is the length of conductor, you know, the diameter of the artery over here? Yeah, the inner diameter will be equivalent to the length of the conductor. Try to answer why that is the case. And this is just one line derivation.
Faraday's induction law.
Faraday's induction law, but why is it that the length of the conductor? We have a blood flowing. It says this is the length of the conductor. Why is that?
Because it's placed like that clamp is placed across
the potential measurement things are like placed here. So blood is the conductor they are talking about, and its length is this. Okay. Okay. This is just the Faraday's induction law. One question. All you have to do is velocity is Q over A. Okay. So the last question. Some of you actually, this was kind of the hardest question in the paper. Some of you also got it correct. Who got this correct?
Me, sir.
Abhishek. Okay, great. Abhishek, did anyone else get it correct? Okay, so I set this question in order to, this is a starting point of an important topic in signals and systems regarding impulse response and step response. I think in the gate, they gave you, okay, here what do you want? If the output of the system corresponding to an input impulse response is this, then h of t is this. So we are given y of t, we want to find h of t. Okay, so this is deconvolution. In the actual gate, what did they give? In this problem, they gave h of t and you have to find y of t, right?
Yes.
Yes. So this is convolution operator. So this is deconvolution operator. And the answer here, if you know how to do this, it's very, very straightforward. Abhishek, can you say how to do that?
Sir, actually, I need to look back to it, sir. How I did it. Because now I don't remember it, sir. What was I was doing there?
I see. Okay. So this is going to be very, very simple. H of t. Okay, so y of t is a step response, right? So this is like, let me write in the standard notation. This is the step response. S of t is this function, okay? Step response is denoted by S of t. Fine. S for step. Okay. Can someone guess the relationship between h of t and S of t? Any of you know it? Okay. Relation is ds by dt.
Yes, sir. I remembered now, sir. Just only.
Okay. Thanks.
It was derivative, sir.
Yes.
Yeah.
So in the gate DM problem, they had this convolution question. So you have to do an integral. I gave the deconvolution problem where you have to take the derivative. That's all you have to do. So derivative of this actually it's equal to b and also equal to d. Try to find out why that is the case. This is a starting point of an important concept in signals and systems. So this is one question where we have to learn for diagnostic 2. And by the way, some of you answered this question correctly. Who did not join us, but some of you answered this question correctly. Fine. This was kind of the hardest problem in the paper. Fine.
Okay, sir.
Okay. So I think we took a look at the paper. The only thing is, now after I find the solution for that alphabetic problem, I'm going to be like, man, how did I miss it? But yeah, that's how things are. So this is the only problem I kind of lost. The solution is simple. Let's all try to go find it out. The moment you figure it out, you will be like, how did we miss it? But first thing, Tuesday class, we'll discuss this. We'll start with this. And today, as I said, it's just an overview. I wanted to give hints, strategies. Rest of the month, we'll go deeper into all these concepts. Fine?
Yes, sir.
Okay, so in like...
Sir?
Yes, please.
Sir, what is the correct option for question number 6?
Question number 6 is... one second. Oh, I changed... what is the question number 6 is this the one you're talking about or this one, right?
Yes, sir.
This is, I think, f of x cubed from
C.
Yes, sir. C.
Yeah, C is the correct answer.
C.
Yes. Okay. Thank you, sir.
Okay. So this was, you notice a couple of things. This is the pace at which we are supposed to give the exam. Okay, 2.5 hours, we covered 65 questions. We discussed the strategies and hints. We also actually looked at all the traps, pitfalls, and all that. But if we had not discussed, we should have spent the time clicking the numericals. So you can solve the gate problem in like 2.5 hours usually. You have like half an hour left at the end of the exam to test out, to get 2 or 3 more additional marks in a lengthy problem. Okay, so this class is, the purpose was like to look at the strategies and hints for all the questions. Did we do that?
Yes, sir.
Yes, and I think all of you did not learn all the questions, but I think all of you learned at least one question, one strategy, right?
Yes, sir.
Yes.
Okay.
Yes, sir.
Okay, that's very good. So now it's time to start mastering this. We'll look at each of these questions in detail. Fine. And please know, I'll re-release this course because the key seems to have changed and I added references in the feedback. I'll re-release this course. Take a look at all the hints that I have put up there. I have also given links to the YouTube videos I'm referring to, books, example problems, or some websites, or even sometimes journal articles. Take a look at that, okay? That's the starting point. Before Tuesday, I will send a schedule for this month on which days, which problems are we going to discuss. I'll send that schedule. I'll do that before Tuesday so that for the rest of the month, we know what the agenda is. Clear?
Okay.
Oh, okay. Okay, then I think if you have any questions, we can stay for a couple of more minutes. Other than, if else, I think we are done. Thanks for being active in this class.
Thank you, sir.
Thank you, sir.
Thank you, everyone. Yeah,
Thank you, sir.
yeah, thank you.
Thank you, sir.
Sir, I want to talk to you regarding some things, strategies. Can I just talk to you tomorrow, sir? Is it okay? Or
Is this
Monday?
Prithvi?
Yeah, sir.
Prithvi, yeah, we can strategies from the gate paper or what strategies?
No, sir. Overall, sir.
Overall strategies. Why don't we have a call sometime tomorrow morning?
So tomorrow morning. Okay, sir.
We can talk now. Just that I can't focus as good as I could do tomorrow.
Yeah, sir.
Okay.
Sir.
Okay, fine. Anything else?
Nothing, sir, from my side.
Okay, thanks for that.
Thank you.
Okay, then. Okay, sure. If there are any questions, post it in WhatsApp. And now let's also once I put up the schedule, let's start discussing questions in WhatsApp. Okay.
Okay, sir.
Okay, great. Thank you everyone for showing up. Have a good Sunday holiday. And of course, Monday we don't have a class. Try to look up some of these things. We'll get back on Tuesday. Okay. Okay. Thank you. Yeah. Thank you.
Thank you,
Yeah,
sir.
yeah. Thank you.
Thank you, sir.